My name is Mike Beard, and I'm with a company called Badu Networks out of Irvine, California. I'm here to talk to you today about the wireless last hop and how it impacts streaming. So before I get started, let me just do a couple of logistical things. One, I am giving away an Apple TV today, so if you registered on the way in, we're going to do a drawing and we're going to give it away at the end of the session here. So actually, we're going to give it away. You're going to have to come by our booth to pick it up, but we're going to pick the winner here and announce it. So make sure you register. Number two, I just want to start with a story. So yesterday when I showed up at the event, I thought I'd go get a bagel, so I went over to the bagel cart, right? And I met a gentleman, looking to see if he's here. Anyway, we started talking, and he noticed that I was going to speak today. And he said, "So what are you speaking about?" And I said, "Well, I'm going to talk about the wireless last hop and the impact of that on end-to-end performance." He goes, "Oh, that's interesting." He said, "My brother works for a big cable company. I'm not going to say any names here. I want to protect the innocent." And he said, "My brother works for a big cable company. He works in infrastructure, and they're getting ready to, offer a service to the market, to consumers, to connect the internet to their house." I said, "Oh, that's pretty cool." He said, "Well, what speeds are they going to offer?" He said, "Well, that's funny because my brother told me that connectivity was a lot more important than throughput, and so anything greater than 0 was good." And I kind of thought about that for a second. I went, well, that's 180 degrees from what I'm going to talk about tomorrow. So the first guy I met at the conference is talking about something that I'm going to talk against, really. And so, I mean, the point of that is that a lot of people don't know about the wireless last hop. What is the wireless last hop? Okay, it's really two things. One is Wi-Fi last mile. So the wireless last hop is something we've coined. It includes the Wi-Fi last mile, which is the last network hop between your access point at your house, or at Starbucks, or at your work, or any Wi-Fi hotspot, like the hotspots that Time Warner Cable's putting out there right now, and a device in the Wi-Fi network. So that last hop between the access point and your wireless device. That's one part of it. The second part of it is the mobile last mile, which is the network hop between the radio towers at the edge of your mobile service provider and your mobile device. So when I refer to wireless last hop today, I'm going to be talking about both those things together. So what impact does the wireless last hop have on end-to-end performance? Okay. So before I get into that, I think it would be worthwhile going over the history of web performance and how we measure web performance through the years. So originally, when the internet started out many years ago, the most important thing was to get your website up, get content on it, make sure it was connected, make sure it always stayed up. And everybody was happy to do that. And then all of a sudden people started saying, we need to start thinking about the end user experience, what the user experiences from my website. So the powers that be invented a benchmark for this. And this may be reviewed for some of you guys, but the original benchmark was called the backbone benchmark. And what this is a measurement of from your web server to the local internet service provider. And it was a good general benchmark for what the user experience would be kind of on the other end in a city, generally. Not real specific to the end user experience, but a pretty good benchmark of what your web page, in the example I'm going to use today, what your web page would take to deliver over that distance. Really not an accurate benchmark of what an end user experience is. So what I'm going to use as an example today would be a web page. So a web page in this particular scenario would take 0.5 seconds to deliver from your web server to your local internet service provider. So after a while, people said, that's good, but it really doesn't measure the end user experience. So what can we do to measure the end user experience? Well, soon after that was added something called the last mile. The last mile is the hop between your internet service provider and your house. Totally different network. Lower bandwidth, usually oversubscribed. So the bet there is that not everybody that's subscribed is going to use it at the same time. But if that happens, then it slows down quite a bit. And this would be the benchmark from the ISP to your house to a wired device. So if you connect into your wireless router at home and not use wireless, then it would be those kinds of speeds. And it's a little more accurate. Using the same example I did before, we got 0.5 seconds from the backbone. You've got another 0.7 seconds over that wireless last hop to your house, to your laptop. And so the total throughput now is, end-to-end is about 1.2 seconds. So you can see that adds some latency to the web page. So at this point, a few years back, something happened that changed all of this forever. This statistic, and this is an old statistic. 71% of internet traffic is delivered across Wi-Fi and mobile networks. In other words, the wireless last hop. Most everybody accesses the internet across the wireless last hop nowadays. But this is not measured in these last two benchmarks that I showed you. So how do you measure this? Well, if you add the wireless last hop to all of this, it definitely impacts the throughput. In this particular case, it would be 0.5 seconds on the backbone, 0.7 seconds across the last mile, and if you're running across a Wi-Fi network, 2 seconds. So now the end-to-end performance becomes 3.2 seconds total. In this example, the wireless last hop was 63% of the end-to-end performance. And this is the kind of impact that the wireless last hop has on all internet traffic, not just videos. So the takeaway from all this is that actual end user experience, what you're experiencing on your laptop or your Wi-Fi device, is measured from end to end with the wireless last hop included. Now I will say at this point that most of the vendors out there that measure end-to-end performance, like Keynote, Gomez, Cashpoint, guys like that, really are just starting to discover this. They're just starting to realize that this is really the end user experience, not the other benchmarks. The other benchmarks are good to get a general concept of what your end user experience is, but this is the true user experience. So what's the impact of the wireless last hop on video delivery? That's what we're here to talk about today. Well, here's one benefit of it. Okay, and this can be caused by a lot of things. I'll be truthful with you. This can be caused by a server overload. The streaming server can be overloaded. The connection to the internet from the data center can be slow. The internet can be crowded. The wireless last hop can be oversubscribed. A lot of people can be using it. But more times than not nowadays, and we do a lot of manual testing, we do Badu, more times than not, it's the wireless last hop. We would say probably more than 50% of the time it's growing. So performance can be lightning fast from your video servers to your house, but if the wireless last hop is slow, the entire experience is bad. I know you've all experienced this when you're looking at video at home or on a busy network, and you see the buffering. So how does this impact the world? Okay, so a few interesting statistics. Online video now accounts for 50% of all mobile traffic. And once again, these are old statistics. These are 6 and 7 months old. Online video users are expected to double to 1.5 billion by 2016. These numbers are crazy. The number of smartphone users who watch video on their smartphone device is going to jump from 71 million to 86 million this year. 20% increase, and that number is getting bigger. 1/3 of all home broadband internet traffic in the U.S. is generated by Netflix videos. I'm one of those users. Okay, YouTube accounts for nearly 1/5 of all mobile data traffic. So all of these things are creating a huge impact on the internet. Here's my favorite one. Consumers give up on online video if it doesn't load in 2 seconds. I don't know about you guys, but I'm a little more understanding than that. I'll give it 2.5 or 3, and then I'm gone. So it's a true thing. So why is streaming so sensitive? There's been a lot of studies about this, and it's because it's continuous, it's easily interrupted, and it's instant feedback. I don't know about you, but I'm a very visual person, so if I'm looking at a video and there's interruptions, it's very annoying to me. I'll turn Netflix off if there's buffering. I'll just do it. I'll just turn off and back later. So the other thing about this is that our expectations are very high. We're very used to high quality video delivery from cable companies and satellite TV, and we expect the same performance across our wireless devices. And it really doesn't happen. And it's probably going to get worse before it gets better. And the reason is because the traffic and the acceptance and the people now starting to use wireless devices for video delivery is growing exponentially, way faster than we can build the infrastructure to handle that. way faster than the wireless router manufacturers are adding capacity to their wireless routers. So it's probably going to get a little worse before it gets better. Wi-Fi networks are busy and they're getting busier. So I'm going to use a personal example here. I think I'm kind of a standard household here. I've got a wife that runs a business out of her house. I've got 3 kids, 2 of them are in college. They play online games. They all have smartphones. They all have iPads. They all have, mobile. They all have laptops for school. And we have a high-end router. I'm not going to tell you the manufacturer, but it's a high-end AC router. And so it's maximum throughput. Good router. I've got my network set up pretty well at home. And because of this, and because of everybody's home and using this, so, we have an Xbox and a PlayStation. Don't ask me why, but we have 2 of those, and they're used quite a bit. My sons will invite their friends over, and they'll sit around a table, and they'll play online games. At the same time, my wife is on her iPad. She runs a designer business, and so she's looking at videos. She's doing video tours of houses, and she's uploading before and after pictures, and she's got videos of her work and what she does. And she's on all the time, and she's surfing all the time. And then I try to work at home. So if I object that I can't, I get a lot of grief. So I go into the office a lot now. But I think I'm a standard example of a household nowadays. I think some households are busier than this. So the Wi-Fi networks are taking the brunt of this. So Wi-Fi network traffic growth, here's some more statistics. 63% of U.S. adults use the internet wirelessly, and that's getting bigger. 86% of tablets require a Wi-Fi connection. 90% of all iPads are used as Wi-Fi devices. And 75% of smartphone owners use Wi-Fi. And there's a reason for this. I know I've got my kids and my wife trained, don't tell her I said that her smartphone automatically jumps on a Wi-Fi network. And the reason is because I've been burned a couple of times with I have my data limit on my mobile provider of 4 gig, and if I go above that, it's very expensive. You guys know this, which is why a lot of people set their smartphones to just jump on a Wi-Fi network whenever they go there. So this number is growing as well. So what I'd like to do is just show you a short video, if I could, and I'll be describing it as I'm letting it run. It's just a 2-minute video. And what it's going to show you is a side-by-side comparison of a 1080p video playing across the wireless laptop. Now I know it's hard to see the data at the top, so I'll tell you what it is. But the video on the right is with our technology in front of the server serving the video out of a data center in Los Angeles. So the data center is about 20 milliseconds away from these 2 phones, and these 2 iPhone 5s are attached to a Wi-Fi network, our office Wi-Fi network, which is very busy because we have 7 or 8 companies that use that same Wi-Fi network. So it's very busy. So there's a lot of congestion here. So the video on the right, you'll see, is going to play very smoothly. It's not going to be interrupted. It's not going to stop. The one on the left stops a few times and he gets behind. So the top numbers up there, just to give you an idea, is the buffered amount. And so the number up there tells you how far ahead of the buffer the stream is, the actual download of the stream is. And on the right, our stream is about 35 seconds ahead of the buffer. And on the left-hand side, it's about 5 seconds behind. So the reason is, so what that causes is the stoppage. It causes the buffering. It causes those things. And the reason I'm showing you this is because it is a big difference when you're going across the Wi-Fi last mile. So this is going to run for just another second. You see all the data in there too. There's a lot of explanation behind what that is. But basically, if you see a solid line, that means that's pretty good throughput. If you see the line drop, it means that the buffer's full. And this is going to get worse with 4K. This is 1080p. And I think a lot of delivery of video nowadays is really at 720 or lower. And the reason is because they want to avoid the buffering. Okay, so basically you get the highest resolution here. It should be over in just a second. But I think you're seeing the difference. The one on the left stops, the one on the right continues to run. Which one would you rather watch? I know what I'd rather watch. So I didn't realize this was so long. So I'm just going to summarize and then open up for questions. Sorry about this delay. Okay, so just to summarize what I've been talking about. This is going to be short because I know you want lunch. Okay, so video usage is growing at a staggering pace. You saw the numbers. 4K video is coming, so are increased expectations. When 4K hits, the infrastructure better be ready for this. And we're probably not going to be, especially the wireless infrastructure. It's probably not going to be ready. So 4K is going to cause more buffering. Wi-Fi networks are busy and getting busier. The Internet of Things is coming. You guys all know what the Internet of Things is. I know I was in a vendor the other day and I saw a crock pot with a wireless device on it. So you can now have a wireless crock pot in your house. You can access from your iPhone and start the crock pot on the way home from work. Go figure. You got security cameras, you got all kinds of stuff, and that's all going to put huge pressure on the wireless router in your house or anywhere. Mobile networks are being overwhelmed. The carriers are trying to put up infrastructure faster than the traffic is growing, but they're being unsuccessful. Most internet traffic travels over the wireless last hop. We saw that 71% number, that's growing. The wireless last hop has a major impact on end-to-end performance. We saw that with my benchmarks that I showed you. And so really the major takeaway here is to maintain and improve the user experience, we must optimize the wireless last hop. We at Badu think that that is the go-forward battleground for performance on the internet. That's causing so much pain right now to everything that if you fix that, a lot of things are going to get better. That's really where we focus. So I mean, this is a 30-second commercial. Okay? So Badu and the wireless last hop. Our products were developed with the wireless last hop in mind. It was built from the ground up. Badu's server-side products can help deliver videos across the wireless last hop from a data center or a cloud at a higher bit rate with little or no buffer from the server side. Badu client-side gateway products can help Wi-Fi networks be more efficient. So we sit right in front of the Wi-Fi router, supporting more wireless devices on the same access point at a higher throughput, impacting video delivery in a very positive way. So if you have more questions or you want to hear more about what we do, please stop by our booth. That's it. Any questions for me? Quiet group, I must have covered everything.
Box hot?
Pardon me?
Box hot, hardware?
So if we're going to
Talk
go
about the integration in a home.
So in a house, so two things. Number one, we have a desktop and we have a rackable appliance for a business, and the desktop can also be used in the home. So it's about this big, and it plugs in between the internet modem and the router, basically. So we just have to be in between those two. And we are talking to some router vendors about embedding our technology in the routers too. That's a good footprint for us. And then we have all the way up to 40 gig boxes for carriers. I mean, so we scale all the way to the internet too. Anything else? I was kind of hoping you guys would ask me about my home network, but
Where's the picture?
Where's the picture? I should have showed a family picture with the router in the background.
You and Matt.
Well, thank you. I really appreciate your time.
Great.